Hi everybody, hope you are doing well. This video is very important and this is related to a very important type of calculations, predicting precipitate formation, whether a precipitate will form or not. In this video, I will teach you a special strategy that will make you confident in solving any problem related to prediction of precipitate. If we have a solid product, this solid product may form a precipitate or may be dissolved. Precipitate will form if the QSB value is greater than the KSB value. And in this case, to achieve equilibrium, the reverse reaction is favored. If the QSB value is less than or equals to the KSB value, precipitate won't form. If the QSB is less than the KSB, it means that this is unsaturated solution. And to achieve equilibrium or retrieve equilibrium, the forward reaction is favored. In case of the QSB equals to the KSB, the reaction is already at equilibrium. KSB is the solubility product constant. This is constant, so it's known, and it is at equilibrium. The QSB is a trial ion product. This is calculated from the concentrations of the ion that form the product. And in this case, equilibrium is not considered. Very important notes to consider if you are solving problems of precipitate prediction. In a certain reaction, the ions dissociate from the ionic reactant and then combine to form the ionic product. Knowing the concentrations of the dissociated ions, known as Ci, and the concentrations of the combined ions in the product, which is Cf, C initial and C final, or initial concentration and final concentration, is crucial to calculate the QCB value. The steps to predict a precipitate. This is the strategy that I mentioned from a while that will help you to be confident solving any problem to predict the precipitate formation. When you have a problem to predict whether a precipitate will form or not, the first step and the most important step is to write the balanced chemical equation of the reaction. Number 2, determine the initial concentration of the precipitate ions, Ci, which are dissociated from the reactant. Third step, determine the final concentration Cf of the precipitate ions using the solubility formula. The initial concentration times the initial volume equals to the final concentration times the final volume. We already have Ci, or the initial concentration, from step number 2. The initial volume and the final volume are known from the problem. The Vi, or the initial volume, is the volume of the reactant. The Vf, or final volume, is the total volume after mixing all the reactants. Step number 4, write the equilibrium equation of the precipitate and calculate the QSB. Calculating the QSB requires the final concentration that is already calculated from step number 3. This means that every step is dependent on the previous step. Example, a drop of silver nitrate. Silver nitrate is a reactant added to NaCl solution. So the reactants are sodium nitrate and NaCl. Both are ionic compounds. It's very important to know how this ionic compound will dissociate. When you have any problem in a side paper, write all the given information. This will help you have anything ready to use, and you will not need to go back every time to look at the problem. The first information we have now is the reactant. We have more pieces of information which are very, very important. We have 0.05 ml of 6 mole per liter of the silver nitrate. This is a volume, and this is the concentration. This is an initial concentration of the silver nitrate. And we have 0.1 mole per liter initial concentration for sodium chloride, and the volume is 1 liter. The question is, does the precipitate of sodium chloride form? The KCB value for the product is given. First, as I mentioned, write the given information in a corner of your paper to help retrieve them easily. These are the given information: the initial volume and the initial concentration of the silver nitrate, and the same for the sodium chloride. From the given information, we know that the final volume is all the volumes added together. Don't forget to convert them to the same unit. Convert the liter into ml, so it's 1000.05 ml as a final volume. The precipitate ions are the ions of the product. The product is silver chloride. Now you have every piece of information given in the problem. Depending on these pieces of information, we estimate some other calculations like the final volume and the precipitate ions. Next, to know whether precipitate will form or not, we have the KSB, by the way. Now we need to compare the QSB to the KSB. If the QSB is greater than the KSB, it means that a precipitate will form. So the missing part here is the QSB. We have to write that. What we need to calculate, the QSB. The QSB equal the concentrations of the ions of the product. Silver chloride, so the ions are silver ion and the chloride ion. So we will move forward to calculate the concentration of the ions of the product. It's time to dive in the solution depending on the same strategy that I just mentioned. Step number 1, write the balanced equation of the reaction. The reaction was the reaction of silver nitrate and sodium chloride. They are ionic compound. The product will be sodium nitrate and silver chloride. Step number 2, determine the initial concentration of the precipitated ions. The ions of the AgCl, the silver chloride, the silver ion and the chloride ion. We will draw the ionic equation for every reactant separately because every reactant will give us one of the ions of the product. The silver nitrate will give us the silver ion. Silver nitrate will dissociate into silver ion and nitrate ion. The product will take the chloride from the sodium chloride. The sodium chloride will dissociate into sodium ion and chloride ion. From this dissociation, this is the initial process that happens in the solution. When two ionic compounds react together in an aqueous solution, all the ions of all the reactant dissociate and become free in the solution, like these 4 ions. This is the intermediate step. Then, every ion will combine with the opposite charge. The silver will combine with the chloride ion, while the sodium will combine with the nitrate ion to form the product sodium nitrate and silver chloride. From this step, we will get the initial concentration of every ion. And we wrote how every reactant dissociate into ions because we need to estimate the initial concentration of the initial ions. Every 1 mole of silver nitrate will provide 1 mole of silver ion. It's 1-to-1 ratio. So every 1 mole will provide 1 mole. But in the problem, we have 6 mole per liter of silver nitrate. So every 6 mole will give 6 mole. So the concentration of the silver ion is 6 mole per liter. The same for the sodium chloride. Every 1 mole of sodium chloride will give 1 mole of chloride ion, 1-to-1 ratio from the given information, 0.1 mole per liter sodium chloride. The same concentration will be for the chloride ion, 0.1 mole per liter. So now we have the initial concentration of the ions before interacting to form the product, silver and the chloride. The initial concentration of the silver, this is the Ci, if you remember, is 6 mole per liter. And the initial concentration of the chloride, Ci for chloride, is 0.1 mole per liter. This is a crucial new information. Step number 3, calculate the concentration of the precipitate ions after combining. The previous step is the concentration before combining, the initial concentration. After combining to form the AgCl or the silver chloride, they combine together, they give a final concentration of these same ions. To calculate these concentrations, we use the solubility formula. The solubility formula is C initial, V initial equals C finals, V final. Everything here is known except the final concentration. We need the final concentration of each atom to calculate the QSB. And the QSB is crucial here to understand the relationship between QSB and the KSB. KSB is given in the problem from this mathematical equation. So the final concentration will equal to the initial concentration times the initial volume divided by the final volume. The final concentration of silver ion equals the initial concentration of silver ion. We calculate this from step number 2, 6 mole per liter, times the initial volume of silver ion. We have this from the problem as a given information divided by the final volume. The final volume is the total volume after mixing all the reactant. We have in this problem 1 liter of sodium chloride equals to 1000 ml and 1 drop of silver nitrate 0.05 ml. We will get the concentration of silver chloride at this number, 3 times 10 to the power negative 4. We will do the same for chloride ion. we get the initial concentration of chloride ion from the previous step, step number 2, 0.1 mole per liter, and the initial volume of chloride ion is the initial volume of its reactant, sodium chloride, which was 1 liter, 1000 ml, and then we will have the concentration is 0.1 mole per liter. Everything is almost done. Now, the fourth step is to write the equilibrium equation and to calculate the QSB from the final concentrations of the mixed ions. Calculate from step 3. The equilibrium equation of the product, silver chloride in aqueous solution, dissociate in silver ion, aqueous, and the chloride ion. The QSB is the concentration of the silver ion and the chloride ion. These are the final concentration because these are from the product. We already calculate them from step number 3. We just multiply them, and then the QSB is 3 times 10 to the power negative 5. We will compare it with the KSB value from the given information from the problem. The KSB value is less than this value, so the QSB is greater than the KSB value. Therefore, silver chloride will precipitate. Follow this strategy. This will help you a lot to solve all of these types of problems. It will make you 100 confident in these types of problems. Thank you guys. See you in the next video.